All right. So, hello, my name is Valmir, and I am here to make this presentation about agile testing, a quality culture in the company's core business. The idea of making this presentation is that I have made this presentation already in some meetups and conferences in Brazil and Europe, but not everyone could join these meetups and conference. So I am recording this presentation so that it can be available on my YouTube channel and then anyone can see it. And for those who don't know me, my name is Valmir and I am a QA engineer. I work in this area since 2004, so more than 10 years. I am the author of the blog talkingaboutTesting.com, where I share lots of content about software testing in general, some hands-on content, some more like to think about. Um, I have also a Medium account where I write the content in English because my blog is all in Portuguese since I am from Brazil. I am also author from the Talking About Testing channel on YouTube, where I share hands-on videos about how to do test automation, and I also talk about career. And this will be available on my YouTube channel, this presentation. Um, Other things, so I have wrote a book about Protractor that is available on English and Portuguese. The Portuguese version is available on Casa do Código, and the English version you can find on LeanPub. And recently I have launched an online school called talkingaboutTesting.cursify.me, where I teach test automation in different ways. So this presentation is based on these two books, Growing Agile, A Coach's Guide to Agile Testing from Karen Greaves and Samantha Lang, and also from this book, Agile Testing, A Practical Guide for Testers and Agile Teams, from Lisa Crispin and Janet Gregory. And of course, it's also about my own experience. So let's talk about what's Agile Testing. I like to think that agile testing is a mindset for software engineering. So when I say that it's a mindset for software engineering, I want to say that we have to think of ourselves in a software development team as software engineers. We don't have to differentiate between roles like I am a front-end developer, you are a back-end developer, I am a software tester. We should be all software engineers and concerned about developing software with quality, right? So agile testing is a different way of thinking about testing. It's not about doing testing in the traditional way where we do manual testing, where testing happens in the end of the process. So it's all about rethinking software testing. We have to forget what we learned about the traditional way of doing testing and understand how to do it better, how to do it in an agile way, and you will see what this means along the presentation. So this is a sentence from a book called Extreme Programming Daily Practices for Software Development from some friends of mine from Brazil, where they say that the QA engineer in the extreme programming discipline helps the customer to choose and write acceptance tests to automate them. He also serves as a coach developer in software testing techniques. He is not responsible for finding trivial bugs, these being responsibility from the developers themselves. He doesn't work isolated. Instead, he's part of the team. He thinks in the tasks that will go to continuous integration pipeline and helps developers in pair to solve issues. So this is what they say QA engineer is in extreme programming discipline. And I would like to add that, and why not, he develops new features he refactors the code, he fixes the bugs he finds, and he always think about testability. So when I said that we should consider ourselves software engineers, we should not just say that the developers should write tests if we don't want to fix the bugs, right? If we don't want to develop new features. So I think if we want to be software engineers, good software engineers, we have to think about all the things from this slide, but also from this one, and always thinking about testability. So in the first book that I showed you before, the authors, they make this comparison about the traditional way of doing testing and the agile way of doing testing, and this is what I will show you first. So in the traditional way of doing testing, testing is a phase. So and this phase happens usually after development. So here you have this tester in front of a Kanban board where you have things to do, you have things for development, and after development then you have things for testing. And only after testing things go to done. And this is very problematic because usually you have more developers than testers in a traditional team, which means that the testing will be a bottleneck. Also, it's problematic because let's say the tester finds bugs here, but the developer that developed that feature, for example, is already working on something else. When he finds a bug, bugs go back to the developer, and then the developer needs to stop what he's doing to fix the bug and then go back to what he was doing. So the lose of focus here is very problematic. So in the agile context, testing is just one more activity, right? So here we have the red squares are development tasks, the pink squares are testing tasks, and in the board you see that you have to do, busy, that could be doing, and during this column the software engineer can be writing features or tests, right? And even better if they are working in pair, writing tests, like let's say a QA engineer and a software developer working together, writing tests first for a functionality, and after that writing the functionality itself, right? So the QA in the agile perspective is part of the board. So in the traditional way, the tester is there just to find bugs, and and people think that a tester is performing good if he's finding lots of bugs. But in the agile way of thinking, we are there to prevent bugs instead of finding them. So it's more about the prevention. What about if we test first? What about if we put tests to run in a continuous integration, so we have like quick feedback and things like that? In the traditional way, the tester is just a checker. There is the test analyst or the test manager who creates test plans, create test cases, that the tester himself just follow this script and say, well, this step passed, this failed, this step passed, this failed, this step passed, and so on and so on. So he's doing manual testing and just checking what someone else thought. He's not thinking. Being an agile tester is more about understanding what are the problems that our users have, and then talking to the users to understand, like, these are the tasks that I thought about. What do you think? Do you have some input? Do you think something here is missing? Do you think I should test some case that is not covered, that it's important for you, and things like that? Another way of thinking in the traditional way is that the tester is there for breaking the system. So it's very similar to like finding as much bugs as possible. So in the agile way, the the QA or the Agile tester is there for helping to build the best system. We want to build software that is bug-free, or as close as possible as bug-free, right? And in the traditional way, the tester is responsible for the quality. So the quality gate is the tester or the testing team. While when we think about Agile, we have to think that the whole team takes responsibility for quality. So it's about the developer is also responsible for writing tests, because the responsibility for the quality is of the whole team. So in this book that these authors created, they have created this testing manifesto, which is very similar to the Agile manifesto, where we have things in the left and in the right. And even if the things in the right are important, we value more the things in the left. So we value testing throughout over at the end. We value preventing bugs over finding bugs. We value testing the understanding over just checking functionalities. We value building the best system over breaking the system. And we value the team responsibility for quality over the tester responsibility. And if I could add something else to this manifesto, I would add that we value automated tests over manual testing. Of course, manual testing is important, but here we have to think that it's more about exploratory testing and dog fooding, and not just about following a test script. In the second book from Lisa Crispin and Janet Gregory, they have this thing called the testing quadrants. And the testing quadrants are basically 4 quadrants, where we have 2 quadrants that focus in technology, and 2 of them that focus in the business. Also, 2 of them serves as techniques for supporting the team, and 2 of them for criticizing the product. So in the first quadrant, we can have test activities such as unit testing for the front end and for the back end, for example. We can have activities like component testing. So these are activities that are very focused in the technology and that support the team, because you can write unit tests, for example, while you are developing a feature, for example. You don't need to have the feature done to write the test. You can even write the tests first. So it's for supporting the development team. In the second quadrant, we are still talking about supporting the team, which means that are things that can be done while the software development is happening, but are more focused in the business. So it's about functional testing, wireframes, simulations. So it's more about testing the functionalities and things like that, things that will affect the end users. But these are things like functional testing, for example, is something that can happen while you are developing something. You don't need to have the application or a specific feature done to then start writing functional testing. You can even start testing first. In the third quadrant, we have things like acceptance testing, usability testing, exploratory testing. So this is still with focus in the business, but more criticizing the product, in terms that in here, the application or a specific feature needs to be complete so that I can run acceptance testing. Or let's say an end user or a client or someone from the business side can test if this behaves as expected. And in the fourth quadrant, we have things that are also criticizing the product. So the product needs to be more kind of complete, but here are focus in technology. So performance testing, load testing, security testing. And one very important thing about these testing quadrants is that the activities that happens in the first 2 quadrants, like unit testing or functional testing or simulations, they are things that are cheaper. Like let's say you find a bug you find a bug with a unit test. It's cheaper for you to fix this bug because the unit test is testing an isolated part of the application, so you know exactly what is failing and you know exactly where you should go to fix the issue. And the application is not complete, or that the feature you are developing is not complete. So it's still under development. It's cheaper to fix things. While if you find issues during acceptance testing or performance testing, for example, you have an application or a feature already kind of complete, and the development team is already working on something else, right? And then you find that's an issue in a feature that you have to, and it's a very critical issue that the development team has, someone from the development team has to stop what he's doing or her to fix the issue. So there's again the thing of like you lose focus, you change context, you work on something, and then you have to change focus again to come back to what you were working on. So it's important when you think about agile testing to understand that agile testing is about taking care about the activities that happen in all these quadrants. There is also this thing called the testing pyramid, which is a concept from Mike Cohn. And this guy, he mentions that for creating software in a sustainable way, we need to test the application in the different layers of the application. And we can think of these layers as like the unit layer, where you are testing isolated parts of the application. You can think about the graphical user interface, like end-to-end testing. And you can think about service testing or integration testing, where you are integrating different components to see if they behave well when integrated, right? And the point here is that you need to focus a lot on unit testing, because this is what will give you the confidence of changing the application and not breaking it. And if you break it, you get quick feedback. And you get quick feedback basically because unit tests, they run very fast. They run in milliseconds or seconds, while when comparing to graphical user interface testing, for example, these are tests that need to open a browser, navigate to URLs, click in buttons and fill forms and things like that, which takes a long time to run. So we need to focus on having lots of unit testing, but just a few of graphical user interface functional testing. And then, of course, we need to have the tests that make the glue between these two parts, so the service testing. And I think Google mentioned in a blog post that they focus on having like 70% of the tests in the unit layer, then 20% of the tests in the service layer, and then only 10% of the tests in the graphical user interface layer, because of the speed of the test execution. You want to have as quick feedback as possible, and also because of cost. As I already mentioned, fixing a bug found in the unit layer, it's much cheaper than fixing a bug in the graphical user interface layer, because when a unit test is failing, you know exactly what is failing. When a graphical user interface is failing, the failure may be because of different reasons. It may be a real bug. It may be the test is broken. It may be just a network issue or something like that. So it's more expensive to understand what is happening in the top of the pyramid when compared to the bottom of it. And there is also this test pyramid variation, where in the top of the pyramid you can differentiate tests in the functional graphical user interface testing and also visual regression testing. And visual regression testing are test scripts that navigate through the application under test, taking screenshots along the way and looking for visual differences based on previously approved screenshots. So this is a kind of new technique that has been used in some companies in the market, and I have experience with it. And it's more about from the graphical user interface layer, testing not just that the functionality is there, but also that the UI is rendered correctly. So it's something that people from UX, UI may see lots of benefits. A variation of the testing pyramid is the bug filter. And the bug filter is something like this. You have in the beginning an infinite set of possible known bugs. And they go to the filter, and the first layer of the filter is the unit testing. And any bug can get there to the unit layer. And then only bugs not reducible by unit testing get to the integration layer of the filter. And then only bugs irreducible by unit or integration tests get to the graphical user interface layer. So you are reducing the amount of bugs that will go to production because you are testing things in different layers. And then only the most subtle bugs reach to the manual testing. And finally, only functionally undetectable bugs make it to production. So it's just to think about it differently from the testing pyramid. It's almost the same thing, but it's just a different way of thinking. There are also antipatterns regarding the testing pyramid. The first one is what they call the ice cream, where you invert the pyramid and you have almost no unit testing, you have just a few integration testing, and you have lots of graphical user interface testing that will take long time to run and will not give you quick feedback, and you have, in the end, lots of manual testing happening, which I have seen manual testing taking like 2 weeks to execute all the regression tests, for example. So this is not agile, because then the feedback loop is not quick. Actually, it takes a long time for you to get feedback from the time you developed something new to the time that you know, well, this is working. And the second anti-pattern is the cupcake, where you have teams working in silos. So you have a department where you have manual testers, and they are doing manual testing. And you have a department of test automators, and these guys, they are doing graphical user interface functional testing or visual regression testing. And then you have the developers doing developing features, fixing bugs, but also creating integration tests, unit tests. But because they work in silos, they don't communicate with each other very well. And then since the manual testers don't know what the test automators and the developers are doing, they will create as much manual test case they can, which will make the feedback loop very long. And the test automators, since they don't know what the manual testers are doing, and the developers, they will write as much graphical user interface testing as they can, which will also which are tests that are very slow compared to unit testing, for example, which will affect the feedback loop as well. And the developers, they don't know what the rest of the teams are doing, and then they will write as much integration testing and unit testing as possible, which is not that bad. But the problem here is that we will have tests being duplicated in different layers of the applications. So something that is being tested in the integration layer is also being tested in the graphical user interface layer, which takes longer to run. So it's not very good, right? Because you should have the right tests in the right layers of the application. That's it about the testing pyramid and its variations and anti-patterns. And now I will talk about the difference between a test manager and a test coach, which I see myself more as a test coach, right? So a test manager, say I. A test manager basically uses people, uses his team of manual testers, for example. He does micromanaging. He needs to know what time you arrive, what time you go home, what exactly were you were doing and things like that. He's not willing to change. He's the one that thinks he knows how to do software testing, and will not accept new ideas. When things go well, he's the one that will take the credits. He's tied to a strict test schedule. So let's say after development, we have 2 weeks for testing and we have to run all the regression and that's it. He works with traditional approach to testing. So testing in the end, doing manual testing, things like that. He considers test execution outside of the scope. He's the manager and the testers are the one that will execute the tests. He will just micromanage them. He restricts the team to execute predefined test cases. So it's that thing about being a checker instead of being an agile tester. He basically writes test case that people have to follow the scripts. In the end, he basically acts like an old school manager, right? While in the other hand, we have a test coach. And this guy say we because he feels part of the team. He wants the team to understand that he's part of this team. It's just one more people there for helping. He coaches people instead of using people. So he has experience with some things and he coaches people to make people better professionals. He does not micromanage people. He trusts in his team and he believes they can manage themselves. He's open to new ideas, so he's not the only one that knows what agile testing is about. So he wants to hear what others think about what can be done to improve the process and things like that. He shares the team accomplishments, so when things go well, they celebrate together, right? He motivates the team to work together. He also develops an amplified testing mindset, which is something I'm trying to do here with this presentation. He executes tasks with the team whenever possible. So he's not just the manager that say you have to follow these scripts. He's there helping the team, putting the hands on really. He gives testers freedom to perform exploratory testing. And in the end, he acts like someone responsible for organizing the test effort to not overload the team. And now I will present you some practices that I have experimented that I think work well if you are an agile testing coach working for a team. And the first thing is about rotate between projects and teams. So you have to analyze the projects and the teams, see which teams are not doing that well in terms of software testing, help them and then move on to another team to help this other team, and then move on to another team, and then at some point you come back to the first team to see what they have improved, and you will be always rotating, right? The second approach is to create a task base to be maintained by the team. So if we want the team to be responsible for the quality and for the tasks, we should not be the ones responsible for writing the tasks only. So a good thing is like create a good task base, create a good task framework with clean code, with no duplications, with good abstractions where people can read the task framework and write the tasks themselves, or fix the tasks themselves, or evolve the task framework themselves. I have done this in different projects with success, and I like to think that an agile tester sometimes needs to have a due date in a team, because at some point everything will be working so smoothly that they can work by themselves without the need for the coach anymore. Pair programming and pair testing. So this is an activity that I really appreciate. Pair programming, in my opinion, is one of the best way of one of the best ways of sharing knowledge between people. And a good thing about pair programming is that, for example, you can work in an approach of test-driven development, TDD, where, let's say, one of the pair is writing the tests, while the other is the one making the tests pass and things like that. So this is a technique that helps on people sharing their knowledge, and then we don't have this thing of oh, but this guy is the one that knows about this part of the application. If we do pair programming, everyone will know about every part of the application. Of course, some ones will have more understanding of some parts, but the thing is that we want to level up this understanding of everyone. Code review. This is an image that I really like about the code quality measurement. That is the what the fucks per minute. So when doing code review, you have to give to the person that created the code good feedback. And if you see code that you can't understand, you were writing and you, what the fuck is that? What the fuck is this shit? Like, you want to give valuable feedback to people so that they can improve their code, and then the code get cleaner, and then when doing code review, anyone can understand what the code does, and then they can focus on the problem that they are trying to solve, right? Another thing that I think a software engineer, an agile software engineer can do is help on refactoring. And refactoring is a technique for making the code more robust or cleaner, or use more modern practices, but the behavior will not change. It's just the structure of the code that will change, but it will change for a better structure. A good way of doing refactoring is practicing test-driven development, where you write a test, then you make the test pass, and then you refactor the code for a better approach, right? One thing that I really think is important if we are doing Agile is think about continuous integration, continuous delivery pipelines. And even better if we think about continuous deployment pipeline. So here is an image that I have created to exemplify what is a continuous integration delivery pipeline. Where, let's say in the beginning here, you have like a software engineer working on a new feature, or fixing a bug, or refactoring a code, or writing tests for some part of the application that has no code coverage. He creates the code and he does a git push. When he does a git push, the continuous integration tool will identify that something changed in the repository, and it will trigger a build. And after the build is done, we can have many stages. And the first stage can be running linting, for example, to check this, the static code, just to see if we are following the practices, the guidelines that were defined by the team. And only if linting pass, then we go to the next stage, where we will run unit testing, for example. And then unit tests have passed, then in the next stage we can run in parallel, for example, integration testing and smoke testing. And then after this is done and every test is green, then we can go to a next stage where we will run regression testing and visual regression testing. And if all these stages pass, then we can have a release candidate that we can deploy in production for our end users. And we have to think about testing these things in production as well. So after deployment in production, we can run again the smoke test in production, the visual regression test in production, to see if things work in production. Because if they don't, then we can roll back to a previous version quickly to not affect the end users. And the thing about having a pipeline is that, let's say you created something new, and we know that, for example, regression testing takes a long time to run, while unit tests take seconds. So when you develop something, you want to have the quickest feedback possible, right? So if the unit tests fail, you will not go to the next stage. The pipeline will break and you will stop here and you have very quick feedback to fix it, to go again to this process. And then when things go to production, we have more confidence that we are not putting bugs in production. This is a book that it's one of my favorites. It's called Clean Code, a handbook of Agile software craftsmanship from Robert C. Martin, or Uncle Bob. I have experimenting doing workshops with teams that I have worked with, of like having sessions of 1 hour, 30 minutes to talk about a specific chapter of this book, for example. And it can be about any other good book, like Extreme Programming or whatever. But the point is that we are sharing with the team what clean code is about. And then everyone has the same understanding. And they can have they can give their inputs about good ways of making code clean. So this is something that I really recommend, doing workshops of like good books to share the knowledge of what is this about, and then all the team can have the same understanding. In this book, Uncle Bob mentions about the Boy Scout rule, which is leave the campground cleaner than you found it, which means in terms of software development, then that when you work on something, on some code, you have to leave the code cleaner than you found it. So if you were working on something and you find a function that is not very descriptive, you can change the name of this function so others that will read this code in the future will, for example, understand better what this code is doing. And this is just an example. Another practice that I really like is coding dojos. In this picture, we were doing a coding dojo of end-to-end testing with a specific framework. So it's everyone working in just one computer. So we have like an exercise. We have to, in this case, we had to create test case for a specific feature. And then we have like one person in the computer writing the tests, writing the code, and others just watching and giving inputs and giving feedback and helping the people that is in the keyboard to achieve the goal. And every 5 minutes, the person that is coding is switched to the person that is besides him, and then we just end the dojo when everyone created some code. And it's a very good practice for sharing knowledge as well. So let's say you want to implement a new testing framework, or you want to implement a new front-end framework, and then you can you have people that have more experience with this, you have people that have less experience, but doing an exercise like this, you can make everyone understand at least the basics of this specific framework, for example. Here are some testimonials of people I have worked with as an Agile testing coach. And the first one, his nickname is Troll, and he mentioned that the automated tests made more sense to me in the moment I needed to refactor an important part of the application. And today I feel good that doing a big refactoring will not compromise my weekend, because I know things are being constantly tested. So the next testimonial is about, it's from Mario Lopez. He said, before understanding the importance of automated tests, it was like more work. But after using tests to guide me on the development, I could think better in the software architecture to solve problems and feel safety during deployment. And the last testimonial is from Edmar Gomes, and he said, having a coach that helps me to develop software with quality in mind gave me more confidence than someone just testing and pointing my errors and mistakes. So in the end, we should not work like this. The tester saying, it's a critical issue, and the developer saying, but I cannot reproduce. It's more about like we have to work together. We are a team. We are all software engineers. So the conclusion of this presentation is that agile testing is about people working as a team to develop software with quality in mind, independent of roles, whether testers or developers. Thank you very much. Here is my Twitter user if you want to follow me. And that's it for today. Thank you very much.